this video, we're going to be continuing our work with shapes and area, and our new focus is going to be on surface area. First, we'll look at what surface area is, and then how we can calculate it for a few specific solids. Then we will look at some examples, and finally finish up with a summary. Surface area is the combined area of all the outside surfaces that make up a three-dimensional solid. So here in front of us we have a variety of different prisms with all different surface areas. And just like finding the area of 2D shapes, finding the area of 3D shapes requires us to find the areas of each of the 2D components that make up the 3D shape, and we can use specific formulas to do this. A rectangular prism is formed by connecting two rectangles by their vertices like this. To find the area of a rectangular prism, we need to find the area of each of its component sides. So that would be the front, back, top, bottom, right-hand side, and left-hand side. As you can see, it's composed of 6 rectangles. By finding the area to each one of these rectangles, you will find the surface area of the rectangular prism. We're now going to look at an example of how to find the surface area of a rectangular prism. So here we have a rectangular prism, and I'm just going to bring up some dimensions. Using this information, we can find the area of each one of the sides and the associated surface area. But it can also be helpful to draw up a net. A net is what this shape would look like if it was unfolded. As you can see, if you unfold this, you see all the component shapes that make up the prism and can calculate them all one at a time. So, in order to solve for the surface area of this particular rectangular prism, we need to solve for the area of each of its component sides. Now we've been given the dimensions, all of the dimensions that we need to do this. We just need to assign them all correctly and realize that these are rectangles that correspond. Surface area of rectangular prism, take 7. So, in order to solve for the surface area of this particular rectangular prism, we need to solve for all of the areas of its component sides. And we can do this because we've been given all the dimensions that we need. So let's solve for the surface area of this rectangular prism. So the surface area is going to be equal to, well, it's going to be equal to 2 times the area of the ends plus 2 times the area of the sides plus 2 times the area of the top or the bottom of this particular rectangular prism. Now we just need to work out what these are going to be. So each of the ends we know is a rectangle, and the ends rectangle's dimension is 3 centimeters by 5 centimeters in height. And we know that this is going to be equal to, well, this area is going to be equal to 3 times 5, or length times breadth, which is equal to 15 centimeters squared. So the area of 2 of these ends is going to be equal to 30 centimeters squared, but we'll get to that in the end. Now, we also know that the side rectangles are 8 centimeters long, and we know that their height is 5 centimeters. So the area of the sides is going to be equal to 8 times 5, which is equal to 40 centimeters squared. And then we have the top and the bottom rectangles. The top and the bottom rectangles, well, we know that they are 8 centimeters long, and then we know that they are 3 centimeters wide. So the area of top is going to be equal to 8 times 3, which is equal to 24 centimeters squared. Okay, so now we've got all the components. We can put them into our rectangular prism formula. So the surface area is going to be equal to 2 times our ends, which is going to be 15, plus 2 times our sides, which we worked out was 40, plus 2 times our top, which is going to be 24. And this works out to be, well, that's 30 plus 80 plus 48, which is equal to, so 30 plus 80 plus 48, which is equal to 158 centimeters
Okay,
squared.
so we've seen from the previous example that calculating the surface area is simply a matter of calculating all the component pieces or component shapes of the prism. So let's look at another example here. Now we can just use the same processes we went through in the previous question, and I'll bring up a net to help you solve for the area of this prism. If you are doing this video and feel like giving this question a go, then be sure to pause the video now and try and solve it. Then hit play when you want to see the answer.
So in order to solve for the surface area of this rectangular prism, what we need to do is find the individual areas of each of its component parts or its sides. And we know that this is going to be equal to, the surface area is going to be equal to 2 times the area of its ends or faces plus 2 times the area of its sides plus 2 times the area of its top or bottom. So if we solve for each of these individual components, we can plug them straight into this formula and we can solve for our surface area. So the area of our ends is going to be equal to, well, the ends are equal to, let's draw a small diagram. We have 3 centimeters by 2 centimeters. So the area is equal to 2 times 3, which equals 6 centimeters squared. And if we look at the top rectangle, we can see that it is 5 centimeters by 3 centimeters. So its area is going to be equal to 15 centimeters squared. And if we look at the sides, we can see that this is going to be 5 centimeters long by 2 centimeters high. And that means that the area is equal to 10 centimeters squared. Now that we have each one of these dimensions, we can plug them into our general formula for the surface area of a rectangular prism. So the surface area is going to be equal to 2 times 6 for the ends, plus 2 times 15 for the sides, plus 2 times 10 for the top and bottom. And that is equal to, well, 12 plus 30 plus 20, which is equal to 62 centimeters squared.
A triangular prism is formed by connecting the vertices of 2 triangles together. To find the area of a triangular prism, we need to find the area of the 2 triangles and 3 rectangles that make up the prism. That means finding the front triangle, back triangle, left-hand side rectangle, right-hand side rectangle, and base rectangle. It's important to remember that in order to find the areas of triangles, we need to know the perpendicular height. So be sure to look out for that and not confuse it with any of the other dimensions. Okay, now that we know what a triangular prism is, let's look at an example of how to solve for the surface area of one. Here we have a triangular prism, but one of the first things I want you to notice is that they've given us the perpendicular height. It will be this straight line here, this height here. So be sure not to get that confused with any of the other dimensions involved. Alright,
So here are all the pieces of information that we need to solve for the area of this triangular prism. And it is important to note that we can do the same thing that we did with the rectangular prism and create a net from all the composite shapes that make up this prism. So here we have that. Now it can be easy to solve if you go through and solve for the area of each one of these individual shapes before eventually writing out what the surface area of the triangular prism is. But it's also just as easy to work out from the diagram above. If you feel like giving this question an attempt first, please pause the video now and then proceed with the video to check your solution. So in order to find the surface area of this triangular prism, we need to find the area of each of its component parts. And that means that we can draw a rough definition or a rough formula of what this is going to be equal to. The surface area is going to be equal to the area of two triangles at the ends plus the area of three rectangles. So now that we have that broad definition, we can work out individually what the area of the triangle is going to be and what the area of each of these rectangles is going to be. So let's start with the area of the triangle. So the area of a triangle is given by the formula is equal to 1 over 2 times base times perpendicular height. So we can see here that they've given us the perpendicular height and the base. So we can solve for the area of the triangle, which is going to be equal to 1 over 2 times 6 times 3.3. And that is equal to 9.9 centimeters squared. But we don't just have one triangle, we have two triangles. So let's multiply this by 2. So the area of two triangles is going to be equal to 9.9 times 2, which is equal to 19.8 centimeters squared. So we've got the first component of our formula. Now we just need to find the next components, which are going to be the area of all these three rectangles. So if we look at the rectangle on the bottom of this particular prism is 8 centimeters long and it's 6 centimeters wide. So the area of the base rectangle is going to be equal to 8 times 6, which is equal to 48 centimeters squared. Okay, now is this base rectangle equal to any of the other rectangles? Well, we can look at the other rectangles and we can see that the dimensions are all different. They all have the same length of 8 centimeters, but they all have different widths. One is 5 centimeters on the right and one is 4 centimeters wide on the left. So let's do the one on the left. On the left-hand side, the length is 8 centimeters and the width is 4 centimeters. So the area of the right rectangle is going to be equal to 8 times 4, which is equal to 32 centimeters squared. Alright, now we just need to solve for our final rectangle, which is going to be the rectangle on the right. Now the rectangle on the right is 5 centimeters wide and 8 centimeters long, so the area, this should be the left. This should be the area of right is going to be equal to 8 times 5, which is equal to 40 centimeters squared. So we have our area of our two triangles, and we have the area of the three rectangles, so we can solve for surface area. So the surface area is going to be equal to 19.8 for the triangles, plus 48 for the base rectangle, plus 32
for the left-hand side rectangle plus 40 for the right-hand side rectangle, and that works out to be 139.8 centimeters squared.
In today's lesson, we learned that surface area is simply the total area on the exterior surface of a three-dimensional solid. And we've seen now that we can use our knowledge of areas of different shapes and the formulas involved in order to solve for the surface area of prisms. Thank you for watching this video. I hope it was helpful for you and that you continue learning more about measurement, geometry, and mathematics in general. Thanks.